Today we will discuss data-driven pest management for sustainable development. We are your presenters, Claudia, Gisemba, and Jillian Solomon. First, let's define data-driven pest management. A pest is any species or organism that reduces the availability, quality, or value of a human resource. Data-driven pest management is leveraging data to develop optimal pest management strategies. This includes using machine learning methods such as regression, neural networks, and Bayesian network-based techniques, among other strategies. The goals of data-driven pest management are to maximize crop yield, maximize profit, minimize yield loss, and minimize cost of pesticide applications. Our case study today focuses on the management of Lygus hesperus in California, where it is especially detrimental to cotton. The plant bug Lygus hesperus is one of the most damaging pests of cotton and a frequent target of insecticide applications. Lygus hesperus causes $30 million in damage to cotton plants each year alone. The tremendous loss calls for an innovative data-driven approach to help farmers determine when and how much pesticide to apply to protect their crops. Without good data-driven processes, farmers rely on their personal experience and intuition to help them determine when and how much pesticide to apply. One problem with using intuition is that it is often flawed by economic incentives. For instance, farmers are more likely to apply pesticide when the cost of the pesticide is low compared to the value of the crop. The problem, therefore, is the lack of computational tools to optimize the trade-off between minimizing yield loss and the cost of pesticide management due to pest damage. Data-driven management strategies. The strategy uses Markov decision process to leverage historical data from 1997 to 2008 and machine learning methods to develop optimal pest management strategies. The main benefit of using computational tools is that they allow farmers to move away from their reliance on intuition and personal experience by leveraging data. Another benefit is that scalability of the results, especially to commercial farms. Using a data-driven approach can help increase profit margins on commercial agriculture, which is a critical part of the global economy. Another benefit is that collecting data from actual farms allow the researchers to quantify how closely and at what times of the growing season current farmer decision-making matches the optimal decisions. This information could be useful in guiding outreach and extension efforts that will have the most beneficial impact of cotton production. There are some limitations of these data-driven processes. Specifically, in the study that used a Markov model to identify an optimal pest management strategy of Lygus hesperus, one main limitation was the assumptions that had to be made. For instance, the researchers had to assume that the value function was constant across pest densities in a single state. Also, the inferences about causal relationships had to be based on strong and untestable assumptions. Another limitation was that the data collected didn't contain the observations associated with high pest densities, and so the researchers didn't feel the most comfortable with these results. A further limitation of the data-driven model is that they consider short-term costs associated with the pesticides, when, in reality, farmers also try to consider the long-term use of pesticides. There's also a problem with implementation. A data-driven Markov model approach has been studied and is considered to provide a robust policy-making tool, even in noisy datasets. A problem with implementation, however, is that farmers are risk-averse. The farmers would follow the recommendation to not apply pesticide 92% of the time, but when the recommendation was to apply pesticide, farmers only did so 10% of the time. Using data-driven pest management strategies is a great way for farmers to develop sustainably. Sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Lygus hesperus affects other crops too, such as alfalfa, strawberries, and lima beans. For sustainable development, we can apply data-driven strategies to these and other crops. Using data-driven methods of pest reduction supports the Millennium Development Goals of environmental sustainability, less pesticide use, developing a global partnership for development, sharing knowledge, and eradicating poverty and hunger, food security. Thank you for learning more about data-driven pest management for sustainable development.